Hey everyone, so welcome to video 2 of my series on building a mobile game. Hope you enjoyed the first video, which was describing what the game is, the tech stack that we're going to use, and now for the second video, we're going to talk about what data will be stored and how it will be stored. And if we have time, the actions that define the app. So why data? So the reason why we talk about data first pretty early on in design is it influences a lot of the design decisions. If you know what data you have to store, then automatically you have to think about what you want to do with the data, how to collect the data, how to transform the data. So thinking about the data early on influences a lot of the design of the app. Because, for example, you don't know what actions or interfaces that your app is going to have unless you know what data that your app has. For example, what do you put in a registration form if you don't know what data you're going to collect? You don't. Or what can a user do if you don't know data that the user object has? It's hard. So that's the reason why we talk about data early on. And we're going to talk about data and where it's stored in each of our, I guess, 4 sections. We're going to talk about what we're going to store in Firebase RTDB. So as mentioned earlier, we're using MongoDB for persistent storage, Firebase RTDB for more of a public push kind of storage where any user takes an action which updates Firebase RTDB, all the other clients that are listening to it will get notified of those changes automatically. And then we're going to talk about what's going to be stored on MongoDB, which is our persistence layer. What we're going to store over time on the server. Then we're going to talk about what's stored locally. So we're going to call this state. So by locally, this is what's stored on your device, what information that needs to be stored on each client. So Firebase RTDB is going to be managed through the server. All the clients are going to be listening to it. MongoDB, we're going to have the database manage it and also read from it so clients don't access it directly. And then local state is each user's local storage on their device. No other users will access it, and it's just so that each device can, this is what each device is keeping track of. Now, what do we put on it? So we need to have a list of rooms. So we have, say, a rooms object this, where we have, say, room blah blah blah, and then we have inside here a bunch of other stuff, and then room blah blah blah, and then inside of there a bunch of other stuff. And for each player we want to keep track of their name, we want to keep track of their status, alive or dead, and then we want to keep track of the current stage of the game, which is night, day, killers, police, etc., which is what's the current stage that our game is at. So keeping in mind that this is what's viewable publicly, so anyone with that room ID, and possibly just overall people in public, because they can just keep on going through room IDs, they're going to be able to see this information, which is why this information is what's publicly available and therefore doesn't include any of that private information of what the user's roles are, because that's kept a secret. And this gets updated by a server. So let's see what we have. We have the name, the status, we have the stage. I think that's pretty much it for the what we want to store in that Firebase RTDB. Then in MongoDB, this is storing kind of our master copy of the data on the server side. This is not viewable by users, so we're going to store a few other administrative things in here. So again, we're going to structure it similar to the above, where we have objects of rooms, which is by the key ID, the room ID. Then we're going to also have players, the name, the status, but also because this is the more administrative side, we want to know what users are saying what. So for example, if we have Tom and Jill as players in a room, you don't want Tom pretending to be Jill and saying that, hey, Jill's going to take this action. So therefore, we want to make it more secure. So we have something called a device ID. The device ID isn't just for security. It's also to identify the players by their device, because each device, if it's assigned a unique device ID, then we know that Jill's phone should be populated with Jill's information, and also that when Jill's phone sends information to us, we only want to allow that device to do what Jill's phone is allowed to do. So that's probably a UID v4, which is just a long string of randomized characters and is reasonably pretty secure. So that covers what's in the room. We also have the stage, similar to above, which is just that. And then also for each player, we also want to have their role. So villager, police, killer, etc. So it's pretty similar to what we're storing in the publicly viewable Firebase RTDB. That is the list of players with their names and their status. What we don't show is the device ID, which is private, and also the role, which is private. And if the only reason was we didn't want the persistence database will store all the information that the Firebase RTDB stores, and the only reason why we're having Firebase RTDB instead of having it all reading from MongoDB is because for MongoDB, you need to connect to the database and you have to run a query to get the current information. But for Firebase RTDB, when you update a specific field, for example, if a player gets killed or when a stage changes, Firebase RTDB, all the clients that are connected to it will listen to that, and therefore, once it changes from, for example, from day to night, all the clients will refresh and have nighttime as their current stage. So that's the array of players in the stage, but we're also going to add some other things in the rooms for maintenance. So we want a created at timestamp, and then an updated at timestamp. So that's more for administrative and also for analytics. We want to know if rooms are no longer being used. So say, for example, people are playing a game and they all decide, hey, let's just stop playing, and the room's just hanging there. The created at tells us that, oh, it's been like a week or two now. You can probably get rid of this room. It also tells us for analytics, for example, how long between the created at and last updated at. That's how long games usually run for example. We also want status. 0 will be hidden. 1 will be active, for example. That's just to, in case you want to keep data for tracking, but the game is kind of over. So for example, if we deactivate a game room, we might still want all the data inside just for tracking purposes, but we don't want people to still be able to join that game room because it's a dead game. Dead game room. So that covers what's in the MongoDB database, and again, that's only accessible from our server. So players do not connect to this database directly. They do not know what's in this database unless our server tells them. So we'll just keep that fairly secure. And then local state refers to what we store in the device. So what do we need to store in the device? We need to store the device ID. Device ID on the first load will be created. So let's just say created at first uh, at app start if not exist. So therefore, let's say the first time user runs the app, we'll just create the ID for them. Or if when they reopen the app and they run again, they'll check to see if the ID exists. If it does exist, then great. If it doesn't, then it'll create it for them. So we also want to store the play